Hi, welcome to another great limit video, and this example is number 5 in my series. And boy, do I have a great limit for us to work with today. Now, before we go crazy with the mathematics, always look at the value that x goes to. In this case, x goes to 64, and substitute 64 into our expression to see what type of answer we obtain. Now, with a wee bit of math, I obtain the answer of 0 over 0. Now this is an indeterminate form, and that's just a nice way of saying that algebra will be our best friend later on. Now don't forget there are other forms of indeterminate answers to look for. Besides 0 over 0, you can have 0 times infinity, or infinity divided by infinity, or infinity minus infinity, or 0 to 0, or infinity to 0, or even 1 to the infinity. Any one of these forms just tells us that you will be using algebra to assist you in evaluating a limit. So let's go and have a look at our beastie. Now, the first thing you'll notice is you've got things like the square root of x's and the cube root of x's and even x's by itself. This is very intimidating. And what we want to do is use a mathematical technique called variable substitution to rearrange this limit in terms of another variable so that it's easier for us to factor. And the question that we always have is, what do I substitute in for what? Now, if you see, or you should see, you got a cube root, and think of a 3 when you see a cube root, and a square root, think of a 2. Think of a number that both 3 and 2 divide evenly into. And for me, a great number would be 6. So I'm going to make the variable substitution u equals the 6th root of x. And this gives me a starting point. So I'm going to start with u equals the 6th root of x. I want to solve this for x, so I'm going to raise both sides to the exponent with 6. So that gives me u to the 6 equals x. And now I'm going to start looking at what do I substitute in for the square root of x. So since I start with u to the 6 equals x, and I want the square root of x, I will do the square root of both sides. And this gives me the square root of u to the 6 equals my square root of x. Or in other words, the square root of x is equal to u cubed, and I can substitute u cubed in for the square root of x. Now I'm going to look at the cube root of x. So I'll start back at u to the 6 equals x. I'll do the cube root of both sides now. So I got the cube root of u to the 6 equals the cube root of x, and the cube root of u to the 6 is simply u squared. So I can make the substitution of u squared in for the cube root of x. Now don't forget, x goes to 64, so I've got to figure out where does u go to. So look back at u equals the 6th root of x, where we started. And because x goes to 64, just substitute 64 in for x. So u equals the 6th root of 64, or in other words, u then would equal 2. So x goes to 64, I can make the substitution, u goes to 2. So our original expression, the limit is x goes to 64 of the cube root of x minus 4 divided by the square root of x minus 8, is equivalent to the limit as u goes to 2 of u squared minus 4 divided by u cubed minus 8. This is a less intimidating expression for us to work with. Now we just simply have to use algebra to assist us with this one. Now I always look at what I hope will cancel out. So look at u goes to 2. Treat that arrow sign like an equal sign and bring the 2 over to the other side. So that becomes u minus 2 goes to 0. And remember, on the indeterminate answer, we have 0 over 0. And we want to cancel that guy out. Therefore, hopefully, I'm looking for u minus 2 someplace in the denominator and u minus 2 someplace on the numerator where I can cancel those beasties out. Now, the numerator is the difference of squares, and we should be very confident with that. The denominator is now a difference of cubes, and we've looked at that, so I'll remind us with our formula technique how to factor a difference of cubes. So we'll apply our algebra. Difference of squares is u minus 2 times u plus 2. We'll apply a formula for the difference of cubes, so we get u minus 2 times u squared plus 2u plus 4. There's a u minus 2 on the numerator and a u minus 2 on the denominator, which we hoped would occur. We can cancel those beasties out, do some house cleaning, make a variable substitution in for 2. There we go. More house cleaning. Obtain the answer 4/12. And because you're great little math students, we can reduce that to 1/3. And that tells us that the limit of our original expression is equal to the limit of our new expression in terms of u, which evaluates to 1/3. Hopefully this is helpful. Thank you.